Thank you.
Kindly be seated, please. I'd like to welcome everyone to the 399th inaugural lecture series of Obafemi Awolowo University, with the lecture title, Making the Soil and Water Environment Conducive for Plants and Man. And the lecture is to be delivered by Professor Jimmy Akinfemi Osunbitan. Professor Akinfemi Osunbitan is a professor of agricultural and environmental engineering in the Faculty of Technology of Obafemi Awolowo University, Ile-Ife. He holds BSc, that was in 1992, MSc 1999,
Okay.
and PhD 2007 degrees from this great institution. His PhD thesis was adjudged to be the best in engineering and technology by the National Universities Commission in 2007. Professor Akinfemi Osunbitan joined the services of Obafemi Awolowo University in February 1994 as a graduate assistant and was promoted to the rank of full professor of soil and water engineering on October 2012. He teaches soil and water engineering courses to both undergraduate and postgraduate students in the Department for Agricultural and Environmental Engineering. Professor J.A. Osunbitan has over 60 publications in reputable journals. The focus of his research work is on soil and water management for improved soil conditions and increased crop yield. He has successfully supervised over 10 MSc, 2 PhD theses, and is currently supervising 3 PhD theses. Professor Osunbitan has held several positions of responsibility in the university. He was the Vice Dean of the Faculty of Technology between 2008 and 2011. Head Department for Agricultural and Environmental Engineering, 2017 to 2020. Member, Campus Aesthetics and Trading Regulatory Committee, 2016 to 2018. Member, Anti-Corruption and Transparency Unit, OAU, 2018 to 2023. And then the Chairman, Campus Aesthetics and Trading Regulatory Committee, 2018 to 2019. He's also a member of the University Board of Survey, 2020 to date. The Chairman, Anti-Corruption and Transparency Unit, 2024 to date. He was involved in the World Bank-funded OAU ICT-driven knowledge park of the African Center of Excellence and is designated as the Environmental and Social Safeguard Officer. Professor Osunbitan is a member of the Nigerian Society of Engineers and the Nigerian Institution of Agricultural Engineers. He's currently registered, and he was the editorial assistant for publications of the Journal of Agricultural Engineering and Technology for 7 years. He served as the secretary of the local organizing committee of West African Society for Agricultural Engineering and the 9th International Conference of the Niger Institution of Agric Engineering in 2009. He was a member of the Journal of Technological and editorial board for over 2 decades. Professor Akinfemi Osunbitan was the recipient of the Engineer Akintola Award for the Best Final Year Project in 1992. He was the University of Newcastle visiting staff on OAU IFES Newcastle Linkage Program and also on DFID Rainwater Harvesting Program. In 2011, he won the Israeli Mashav Scholarship to the Hebrew University of Jerusalem in Israel. He's an ordained pastor in the Redeemed Christian Church of God and is happily married to Pastor Mrs. Lydia Adenike Osunbitan and are blessed with 3 precious children. Please join me in welcoming Professor Jimmy Akinfemi Osunbitan to deliver his lecture. Thank you.
Mr. Vice Chancellor, sir, principal officers of the university, distinguished guests, ladies and gentlemen. It is with a grateful heart to the Almighty God that I stand before you this afternoon to deliver the 399th inaugural lecture of Obafemi Awolowo University. This is the 8th inaugural lecture to be delivered from the Department of Agric and Environmental Engineering of this university. The inaugural lecture of today, titled Making the Soil and Water Conducive for Plants and Man, is to formally celebrate the Chair of Agricultural Engineering, which was established for me in the year 2012. I agree with what King Solomon said in the Holy Bible, that to everything there is a season and a time to every purpose under the heaven, and that God has made everything beautiful in its time. The timing of this inaugural lecture is unique because I believe that the year 2025 is a landmark year. Mr. Vice Chancellor, sir, permit me to briefly share my background and the inspiration behind my research focus. As a final year student in the then Department of Agric Engineering, I specialized in farm power and machinery. My final year project titled Development of a Low-Cost Incubator, which was supervised by Professor Oe Ajayi, former DVC admin, won the Best Project Award that year. Ironically, my interest later shifted to soil and water engineering during my national youth service at the Federal University of Agric Makurdi. A prolonged academic strike gave me ample time at the university library, where I developed a deeper passion for the field of soil and water engineering. I was admitted to the postgraduate program in industrial engineering at the University of Ibadan and was also assured of a job at the Nigeria Tobacco Company, Ibadan, where I had previously completed my COS. Around the same time, I learned of an opening for a graduate assistant at OAU. Two positions were available: soil and water engineering and farm structures. Driven by my newfound interest, I applied for the soil and water engineering option and was offered the position. Choosing between Ibadan and Ife was tough for me, but by divine guidance, I accepted the appointment as a graduate assistant in this great university, which marked the beginning of my journey in the field of soil and water engineering. In this lecture, I intend to present my contributions to research in the general area of soil and water engineering, while focusing on the management of soil and water for improved soil conditions and increased crop yield. Soil, water, plant, man relationship. Soil serves as storehouse of water for man and plant. Irrigation and rainwater become available to plants through the soil. Plants grow on soil, which provide them with water and nutrients. Thus, water, which carries a large amount of nutrients, is essential in large quantities for the successful growth of crop in soil. Soil is the reservoir that stores the water needed by plant to grow in order for man to eat our food. Mr. Vice Chancellor, sir, distinguished audience, permit me to refer you again to a quotation from the Holy Bible. When God instructed Prophet Ezekiel to speak a parable to the house of Israel, the book of Ezekiel chapter 17, verse 8 says, "The vine was planted in a good soil by great waters, that it might bring forth branches, and that it might bear fruit, that it might be a good vine." The vine as a plant was good for consumption by man because it was planted in good soil with great water. This shows that there is a close relationship between soil, water, plants, and man. Soil. Soil is a three-phase system consisting of solid, liquid, and gases. The solid phase of soil is made up of minerals and organic matter, while water makes the liquid phase, and soil air form the gaseous phase. Of all the earth's crustal resources, the one we take most for granted is soil. As terrestrial animals, we depend on soil for life, and yet most people think of it in negative terms. To understand the potential for feeding the world on a sustainable basis, we need to know how soil is formed, how it is being lost, and what can be done to protect and rebuild good agricultural soil. An American writer and philosopher by the name Aldo Leopold was reported to have said, "We abuse the land because we regard it as a commodity belonging to us. When we see land as a community to which we belong, we will begin to use it with love and respect." With careful husbandry, soil can be replenished and renewed. Water. Water is one of the most common substances in the world. It covers 71% of the Earth's surface, and it is vital for all known forms of life. The question that has always been asked by policymakers in the area of water is water a resource or a commodity? By the fourth sentence of the Water Framework Directives of the European Community in the year 2000, water is not a commercial product like any other, but rather a heritage which must be protected, defended, and treated as such. Otherwise, it will not be adequate to meet the expected requirement. Our study on water sources and demand in southwest Nigeria affirmed that many people do not have access to piped water. Ogedengbe 1997 in his inaugural lecture stated that the amount of water supplied per capita per day in the southwest Nigeria is less than 25 liters. The rapid growth in population is not helping matters. Shongodo in 1993 stated that the rapidly expanding population has resulted in the various water sources not fulfilling the requirement of consumption. The former United Nations Secretary General, Mr. Ban Ki-moon, at the World Economic Forum in the year 2008 also stated that population growth will make the problem of water availability worse. According to him, as the global economic grows, so will it task. Categories of water use. The three major water usage categories are water used in agriculture, water for industrial use, and domestic water use. Globally, water used for agriculture accounts for 70% of the total usage. However, in the developed countries, most of the water is used for industry. Agriculture accounts for 70% of global water use, while it is more than that in the developing countries. Moreover, in all the regions of the world except the United States of America and Europe, agriculture accounts for more water usage. Agricultural water use. Worldwide, crop irrigation is responsible for 2/3 of water withdrawal and 85% of consumption. Irrigation is the artificial application of water to soil for the purpose of crop production. Conventionally, there are 4 different types of irrigation based on water application methods: surface irrigation, subsurface irrigation, sprinkler irrigations, and drip irrigation. Mr. Vice Chancellor, sir, distinguished audience, it will interest you to know that the irrigation system and practice are as old as creation. According to the story of creation as recorded in the Bible, and I quote, "This is the story about the creation of the sky and the earth. This is what happened when the Lord God made the earth and the sky. This was before there were plants on the earth. Nothing was growing in the field because the Lord God had not yet made it rain on the earth, and there was no one to care for the plants. So water came off from the earth and spread over the ground. At this particular time, rain had not fallen. So the earth was watered from ground upward. which is a type of irrigation that is called subsurface or capillary irrigation. At another time in the history of creation, it was recorded that a river flowed from Eden and watered the garden. The river then separated and became 4 smaller rivers. Water from the river went out of Eden to water the garden planted by God, which is another type of irrigation that can be referred to as surface or gravity irrigation. Sprinkler irrigation system was designed originally to simulate natural rainfall, while the drip irrigation system is a promising technology for reducing irrigation water use. Drip or trickle irrigation system release a carefully regulated amount of water drop by drop through perforations or what is known as emitters just above plant root, so that nearly all water is used by plants. Plants grow on soil that provide them with water and nutrients. They absorb the water from soil mainly through the root and use only 1 to 1.5% of the volume of water absorbed for building their vegetative structures and performing various physiological and biochemical activities. The rest of the water absorbed is lost through transpiration. This close relationship between soil, water, and plant should be carefully understood in order to decide the time and depth of irrigation and to make efficient use of irrigation water. An excess or deficit of soil water hinders plant growth and thereby reduces the yield. Relationship between human and plant. There is an ecological relationship between man and plant. Plants produce oxygen through photosynthesis, which is essential for human life, while man emits carbon dioxide, which plants use for photosynthesis. In the ultimate analysis, there is an interdependent relationship between soil, water, plant, and man. Plant require nutrient elements and water from the soil to grow. Man relies on plants for food, and plants rely on man for care and conservation. Sustainability. Mr. Vice Chancellor, sir, distinguished audience, the important question that we should all ask ourselves is, can the earth sustain our current lifestyle, and will there be adequate natural resources for future generations? These are some of the most important questions in environmental science and engineering today. We depend on nature for food, we depend on nature for water, for energy, for oxygen, for waste disposal, and other life support services. Sustainability means that we must not use up resources or create waste faster than nature can replenish and recycle them. Although we may be able to overspend nature's budget temporarily, future generations will have to pay the debt we leave behind. Living sustainably, therefore, means meeting our own need without compromising the ability of the future generations to meet their own needs. Agricultural sustainability. The conservation of natural resources implies their utilization in a way that maintains high level of crop production while improving environmental quality. Sustainable agriculture, therefore, involves sustained productivity as well as the protection of natural resources. The concept of soil quality is crucial for sustainable production. What is soil quality? Soil quality refers to the soil's capacity to perform its function. It is the ability of soil to sustain the production of biomass in order to meet basic necessity of a growing human population. On the other hand, soil degradation is the decline in soil quality, making it unable to carry out some of its main functions, which leads to lower crop production. Thus, a degraded soil cannot perform specific function of interest to plant and man. If the land is barren as a result of poor soil quality and the water in the same location is bad, crop will not grow for man to eat. This was the situation of the children of Israel during the time of Prophet Elisha, as recorded in the Holy Bible. And I quote, "The people of the city of Jericho told Elisha, The city's location is as good as you will ever find, but the water is bad and the land cannot grow crop. 2 Kings chapter 2 verse 19. This is the condition of so many lands in this nation. The location of many cities are good, but their soil and water are bad. And as a result, the land is unable to grow crop. There is therefore the need to make the soil and water environment conducive for plants and man, if the soil is to continue to perform its numerous function. Mr. Vice Chancellor, sir, distinguished audience, ladies and gentlemen, this has been the focus of my research activities over the last 3 decades since I joined the services of this university. And the topic of my inaugural lecture, which in a broader view is presented as making soil and water environment conducive for plants and man. My contributions to making soil and water environment conducive for plants and man. The focus of my research work is on soil and water management for improved soil conditions and ultimately increased crop yield. My earliest efforts, however, were directed at the computer-aided design of irrigation systems, where computer algorithms were developed to perform the design calculation for sprinkler irrigation systems. Computer-aided irrigation system design. The growing sophistication of computing machinery has not only made possible the rapid and accurate calculation of the complex parameters involved in irrigation system design, but it has also been a catalytic factor in the evolution of several mathematical theories and methods developed in the field of water resources. A computer would carry out instructions and give accurate results only if it has been programmed to do so. I, under the supervision of late Professor H.O. Fakunda, took advantage of the existence of computers to make contributions in the designs of irrigation systems. Our contributions include cost comparison of different sprinkler irrigation systems, the development of a computer algorithm for solid set move, as well as center pivot sprinkler irrigation system, modeling of pressure variation along the laterals of a center pivot irrigation system, and the development of computer program for the design of vegetated waterways. Economics is an extremely important consideration in pipeline design. Pipelines are normally designed to deliver water at the required pressure and flow rate throughout the irrigation system with minimum total cost. Pipe diameter and wall thickness, the amount of energy lost, and the size and type of pump are major factors affecting total cost. A good sprinkler irrigation system has an economical balance between pipe cost and power cost. The larger the pipe, the more expensive it is. More pumping power, however, is needed to force water through small pipes because of increased water friction. Another factor to consider in the planning of sprinkler irrigation system is the escalating cost of energy. An escalation factor can be used to evaluate the increasing cost of energy over the useful life of the system. Mr. Vice Chancellor, sir, we have been able to develop a computer algorithm that performs the calculation of the total annual cost of operating several pipe sizes of lateral pipe with the aim of determining the most economical pipe size for sprinkler irrigation system. The program takes into consideration the annual interest rate and energy cost escalation rate to select the most economical pipe size for a sprinkler irrigation system. Soil properties as influenced by soil amendments. Soil property is directly related to soil quality, though soil quality is concerned with some measure of a property of or function of soil. Hydraulic conductivity, soil porosity, and water permeability. In a study carried out by Adekalu and Osunbitan, 1995, the saturated hydraulic conductivity of 5 different southwestern soil series increased with an increase in organic matter level. The optimum moisture content was found to be positively correlated with the sand content of the soil. In other studies on soil porosity and water permeability of two different southwestern Nigerian agricultural soil treated with poultry waste, cow dung, and goat dung, the soil porosity of the two soils increased with an increase in percent organic waste incorporation. Mulching effect on infiltration, runoff, sediment yield, and soil loss. The need to reduce surface runoff on agricultural soil and increase crop productivity has led to the use of crop residue as mulching on agricultural feed. The process of erosion and sediment transport by rainwater is selective in terms of particle size and weight. Generally, the coastal sediment deposit first, and the final one move further. As a result, suspended sediment usually have more fine and less dense particles. Because these fine particles usually contain higher amount of adsorbed chemicals, it follows that eroded sediment fractions and its relationship with the original soil mass could be used to explain the risk of surface water pollution. Soil cross strength and soil compaction. One of the most essential factors for seedling germination and emergence and crop growth in general is soil moisture. Seedling obtain moisture through the soil from precipitation and irrigation. However, this could produce crust that may retard or prevent emergence if the water is not applied with the suitable intensity and duration. Soil crust results from the breaking down of soil aggregate, movement of fine particles into the upper few centimeters, and compaction of the soil surface to form a thin film which restrict further entering of water. In one of our studies, we obtained linear and multiple regression equations relating crust strength to rainfall duration and intensity. The strength of the crust increased with increasing rainfall intensity and duration before it starts to decrease at very high intensities and duration. It was concluded from the study that since weak crust favors seedling emergence, water should be applied at low intensities for short durations as pre-emergence irrigation, or planting should be delayed till rainfall is of shorter duration and low intensities. The crust formed at high intensities and duration is not desirable as surface ponding set in, resulting in runoff and consequent erosion of the topsoil under field conditions. Compaction of agricultural field results mainly from rainfall or irrigation and farm traffic, with the effect of farm traffic being more severe. Adekalu and Osunbitan reported that the maximum dry density obtained by compaction decreased with increasing level of organic waste, confirming the earlier report by Owu et al. Maximum dry density and optimum moisture content level for some soil series in southwestern Nigeria with different level of organic matter and compaction levels were related to sand and seed content. Mr. Vice Chancellor, sir, in Nigeria, the cost of farm machinery operation has been a major concern in the past. Apart from the high initial cost of farm tractors, the high fuel cost has now led to a substantial increase in operational cost of agricultural mechanization. The draft force required by a tractor in pulling equipment through the soil is a function of the shear strength of the soil. The higher the draft force, the higher the fuel consumption of the tractor. The dry density of soil at traffic increases with moisture content up to a maximum value at a predetermined critical moisture content, which is below the liquid limit of the soil, and thereafter decreases with moisture content. Thus, farm operations are better performed below the critical moisture content when the soil is relatively dry. If the moisture content of the soil is low, individual soil particles cannot come together and there will be air voids. On the other hand, if the moisture content is high, there will be a greater flow of particles when pressure is applied. But these particles will be separated by a film of moisture. When the soil dries, the film of water disappears, leaving behind ear spaces. Thus, too low moisture content and too high moisture content are undesirable. Our study investigated the effect of applying different compactive efforts at varying moisture content on the physical and strength characteristics of three prominent agricultural soils in southwestern Nigeria. It was noted from the study that the higher compaction level increased the dry density and shear strength of the soil, while shear strength decreased with increasing moisture content of the soil for all the compaction levels. From our findings, we derive a multiple regression equation relating the significant components. Tillage effect on soil properties. Reduction of labor requirement has been the principal motivating force for the agricultural mechanization. The application of machines to agricultural production has been one of the outstanding developments in developed countries. However, tillage operation does not have to be with heavy-duty machines like tractors. Depending on soil type and the availability of agrochemicals, zero tillage, or what is called minimum tillage, can give better results. Tillage operation is as old as mankind. Genesis chapter 2 verse 15 says, "And Jehovah Elohim took man and put him into the garden of Eden to till it and to guide it." The primary assignment given by God to the first man he created, according to the Holy Bible, is to till the ground. That is to perform tillage operation. I therefore congratulate as many of us who are involved in the work of tillage, because we are doing the primary assignment given to man by God. Our study on tillage effects on some soil properties asserted that soil bulk density and the penetration resistance of loamy sand soil decreased with an increase in the intensity of soil loosening by tillage operation. Both soil bulk density and penetration resistance increased with an increase in length of time after tillage operation. Soil saturated hydraulic conductivity decreased with the degree of soil manipulation during tillage operation. Crop yield as affected by soil tillage and other treatments. Achieving optimum crop yield has always been a challenge for the farmer due to ever-changing environmental conditions. The factors that influence crop yield include soil condition, water availability in the soil, and the quality of seed planted. Tillage operation is one of the soil management factors that can affect water storage properties of soil and thereby influence crop yield. In one of our studies, we examined the growth and yield response of cowpea to tillage and irrigation water deficit using a line source sprinkler system. It was observed from the study that minimum tillage produced greater cowpea yield than conventional tillage, with the difference becoming more pronounced with decreasing water application. It was also noted from the study that conventional tillage produced greater root development in cowpea than minimum tillage. Hence, it will be better suited for root crops, especially when there is high rainfall, as conventional tillage also provide good drainage. In other studies, we analyzed the effect of poultry waste incorporation into the soil on the yield and water use efficiency of jute mallow, popularly known as ewedu in Yoruba land. The study developed a relationship between the dry matter yield of the vegetable and the organic waste addition to the soil. It was noted from the study that both the dry matter yield and water use efficiency of the vegetable first increased to maximum with increasing poultry waste incorporation from 0% to 2% before decreasing. The relationship between the dry matter yield and organic waste incorporation is a polynomial of the third order. Using the relationship, the optimum level of poultry manure for the highest dry matter yield is exactly 2.24%, which translates to 18 tons per hectare. We therefore concluded that jute mallow requires a relatively low irrigation interval and poultry manure for a good yield. Surface and groundwater for small-scale irrigation. Knowing that irrigation water can be obtained from two sources, our study evaluated the quantity and the quality of groundwater for irrigation in the basement complex of Ile-Ife, Nigeria, and found that the groundwater yield in this area can be as much as 100 meter cube per day. An examination of the groundwater parameter and the crop water requirement from our study indicates that the supply could meet the demand, at least on a small-scale irrigation project in the area underlain by the basement complex. It was also observed from the study that most of the sampled groundwater in this area is within the low electrical conductivity limit. Agricultural chemicals and waste in the environment. February 2005, while justifying the repositioning of agricultural engineering profession and the need to change the name of the department to Agric and Environmental Engineering, stated that the interaction between soil, water, and the atmosphere, which induces numerous effects on the human and plant environment, are within the scope of the discipline of Agric Engineering. One of the sources of soil contamination is agriculture. Soils that are in agricultural use have been affected by different treatments, either deliberately or indeliberately. Some treatments, such as organic or inorganic fertilizers and agrochemicals, are added deliberately. Fertilizers are added to improve the capacity of the soil to provide nutrient elements for crops, while pesticides are used to control pests and diseases. However, the use of chemicals in agricultural watershed has been recognized as a potential source of environmental pollution, especially with respect to soil and water quality. Mr. Vice Chancellor, sir, in the area of agricultural and agro-environmental engineering, our work, my PhD supervisors, Professor P.O. Aino, Professor K.O. Adekalu, and I, has contributed to the fundamental knowledge on the absorption of heavy metal from fungicide to soil particles, as well as their mobility within the soil environment. To the glory of God, my PhD thesis, supervised by these erudite professors, was adjudged by the National University Commission as the best PhD thesis in the discipline of engineering / technology within the Nigeria university system in the year 2007. Cassava wastewater in the environment. Effluents from cassava processing factories have been known to have very strong strength and potent ability to pollute both land and water bodies. Cassava processing effluents are a mixture of liquid waste as well as other wash water used in the industry. Part of the effluent from the processing of this tuber crop infiltrate into the soil, while the remaining part that is left in the soil is easily washed away by runoff into nearby stream. Agricultural waste, wastewater, and reuse. In every human life, unwanted materials are generated and then discarded simply because they are considered to be waste. However, there are different ways of dealing with waste, starting with the most beneficial and working down to disposal, which is the worst way of getting rid of waste. Different options of dealing with waste are reduction, reuse, recycling, recovery, and disposal. Disposal is about finding a place to get rid of waste that cannot be treated by any of the other alternatives. Reduction is the process of producing less waste. Reuse is using a waste product without further transformation and without changing its shape or original nature. Recycling is when the waste material is reprocessed before being used to make new product. Recycling is treating the materials as valuable rather than a waste. A renowned biologist who helped to initiate the modern environmental movement by the name Barry Commoner reportedly said, everything is connected to everything else and everything must go somewhere. Mr. Vice Chancellor, sir, in the area of waste and waste water treatment and reuse, our work, my PhD students, now Dr. Toeshe Oyewusi and Dr. Olayinka Omotosho and I, has contributed to the fundamental knowledge of waste and wastewater treatment and reuse in order to protect adjacent land and water bodies around Canal processing industry from pollution by canal wastewater. A laboratory scale treatment set up for treatment of wastewater from a canal processing factory was established, and pilot scale plant for on-site canal processing effluent treatment was also designed. We then later investigated the effect of using the treated wastewater for irrigation on the growth of yield of two vegetables. The result revealed that the treated wastewater can be safely reused in the cultivation of vegetables at a concentration not greater than 50%. Farming activities in a country where 60 to 70% of the population is involved in agricultural related activities will definitely result in the production of various economic products, from which many types of residues that are biomass materials containing an enormous amount of energy are left as waste material after harvest. Presently, agro-waste management practice in this country is that of burning on the farm or allowing them to decay on the farm. Any of these two approaches causes environmental contamination and pollution. Aside from also resulting to enormous waste of resources, burning of agricultural waste on a farmland affects soil biodiversity, geomorphic processes, and volatilizes a large amount of nutrients in soil, including soil organic matter. While black carbon and particulate matters emitted during the process of the burning is also worrisome. A theoretical physicist by the name Albert Einstein said, "The complex problem we face today will not be solved by the same level of thinking that created the problem. Therefore, there is a need to change our approach in handling agricultural solid waste if the soil environment is to be conducive for plant and man." It has always been said, you want a new result, change your method. And that is what led us to study on compost extract for fertigation. Composting is one of the most common waste management technologies in converting biodegradable agricultural waste. It is the breakdown of organic compounds in biodegradable waste into nutrients in the presence of oxygen, water, and microorganisms. Application of compost to soil in place of fresh manure has some advantages, but may also have some disadvantages. Some of the disadvantages include slow discharge of nutrients into the soil and environmental contamination that result from high application rate due to low nitrogen concentration of the compost. Compost extract is a soluble form of compost which can be prepared in different ways using compost as an initial substrate. It is the water extraction of soaked compost that contains soluble nutrients. Application of compost extract can be done through a system of fertigation because it gives the opportunity to derive adequate nutritional values of compost application. Fertigation is a system whereby fertilizer are incorporated into irrigation water to be applied to plants to achieve better efficiency of fertilizer use, resulting in high yield. Our studies extracted the nutrients from composted chicken manure and applied it as liquid organic fertilizer. We also investigated the effect of processing parameters for compost nutrient extractions on the growth and yield parameter of two vegetables and examined the effect of the compost extract application on some soil physical and chemical properties after harvest. Other contributions. Mr. Vice Chancellor, sir, ladies and gentlemen, the three major activities of an academic are teaching, research, and community services. I have spent the last 3 decades of my life doing all these 3 activities. My contribution is not limited to research alone. I have made significant contributions in the area of teaching, capacity building, and mentoring of students and staff at the department, faculty, and university level. I teach both undergraduate and postgraduate students in the Department of Agric and Environmental Engineering. As visiting professor or adjunct lecturer, I have also contributed to training students both at undergraduate and postgraduate levels at Covenant University Ota and Joseph Ayo Babalola University Kejara Keji. Many of these former students are now established in their chosen careers. I have supervised and I'm still supervising both masters and PhD students. Consultancy services and capacity building. In my earlier days as a graduate assistant, Professor Obafemi Ajibola, former Deputy Vice Chancellor Admin and retired Professor of Agric Engineering, introduced me to consultancy services. I was one of the resource persons for TechnoServe that surveyed processors and fabricators of agricultural implement in Nigeria. I also participated as a resource person under his supervision for the National Agricultural Land Development Agency on the formulation of soil conservation plan and design of conservation structures for the NADA project in Igoyeju, a local government area of Lagos State. I was included among the team that carried out surveys sponsored by UNDP on the capacity and agro-technology needs of women in Osun and Ondo State, as well as the assessment of agro-processing centers in Osun State. I also participated as a resource person for New Nigerian Foundation on the Ofada Rice Baseline Study in Ogun, Lagos, Osun, and Ekiti State of Nigeria. Some of the general information obtained on the field is not only submitted as technical reports, but also published in reputable journals. With the exit of Professor Ajibola from the university, Professor Emo Fabrode, former Vice Chancellor of OAU, who is unavoidably absent here, out of the country, took over the leadership position of the Post-Harvest Research Group founded by Professor Ajibola. The scope of the group was enlarged to include socio-economists, policy analysts, and water resource engineers, with the international partners from the University of Newcastle and support from the British Fund for International Cooperation in Higher Education of the Department of International Development, DFID. The group embarked on rainwater harvesting research activities with the aim of assessing the needs and uptake promotion of rainwater harvesting research in Nigeria. I have to include this rainwater harvesting work. Shortly before we came in, the VC mentioned that is going to hear about rainwater harvesting. And I'm happy to say that the study on rainwater harvesting, which I was actively involved in, produced 2 PhD graduates. One of them is already a professor and current head of the Department of Agric Engineering. By the grace of God, I have had opportunities to travel out of the country for various academic activities. I was at the University of Newcastle upon time, United Kingdom, for an exchange program. At another time, the same university on DFID rainwater harvesting program. I was in Israel at the Hebrew University of Jerusalem on Israeli Marshall Scholarship, at Minyan University, El Minyan, Egypt, for international conference, at Munich, Germany, for practical international workshop on lysimeter and sap flow. Services within and outside the university. Administratively, I've had the opportunity of holding some positions of responsibility in this university. I was the Vice Dean of Faculty of Technology, Head Department of Agric and Environmental Engineering, member and later appointed as the Chairman, Campus Aesthetic and Trading Regulatory Committee, member and later appointed presently as the chairman of Anti-Corruption and Transparency Unit of OAU, member, University Board of Survey, and presently the African Center of Excellence Environmental and Social Safeguard Officer for OAU ICT-driven Knowledge Park. I've also served in various other committees at the departmental, faculty, and university levels. I have served as an internal examiner to some departments in the university and external examiners to some institutions in the country. The institutions include University of Agriculture, Abeokuta, University of Ibadan, Covenant University, Ota, and Federal University of Technology, Akure. To the glory of God, I have also assisted in assessing colleagues within the university and in several other institutions in the country to the rank of professor or reader. The institutions include University of Maiduguri, University of Nigeria, Nsukka, Ladoke Akintola University of Technology, Lautech, Ogumosho, Ekiti State University, EXU, and Ambrose Ali University, Ekoma. I've contributed my quota to the development of education in the country. I've been a member of several NUC accreditation teams for the accreditation of programs related to my field in some federal and state universities in the country. I was the coordinator of all the Redeemed Christian Church of God schools, secondary school, and primary schools in Osun State for 7 years. Presently, the coordinator of the schools in Ife and Ijesha lands. By the grace of God, I have been the chairman, board of governors of the Redeemer International Academy, an international secondary school located at Ifewara for the past 6 years. Concluding remarks. Mr. Vice Chancellor, sir, I have tried in this lecture to present some of the activities that have engaged my research time in the university. I've shown in this lecture that creating a conducive soil and water environment for plant and man is key to agricultural sustainability and promotion of environmental health. The capacity of soil to provide nutrient elements for crops and vegetables, as well as the capacity to store water, can be greatly enhanced with some of the soil amendments presented in this lecture. We should all remember that the soil beneath our feet, the groundwater and the water that flows around us are not mere resources, but sacred trust handed down through generations. Their earth reflects our stewardship, and their degradation echoes our neglect. The future of agriculture, food security, and indeed human survival depend on what we sow today into our soil and how we care for every drop of water. From this lecture, one truth stands clear. Our survival and prosperity are deeply rooted in the earth of our soil and water. I urge us all to recognize the intricate relationship between soil, water, plant, and man. The earth of our planet depends on our ability to manage these vital resources sustainably. These natural resources are not infinite. They require careful management. They require scientific innovation and a commitment to sustainability. If we nurture the soil, it will nourish us. If we protect our water, it will sustain us. But if we neglect them, we jeopardize not just our present, but the future of generations to come. Let us all live here as advocates of a greener tomorrow, champion of soil integrity and guidance of our watershed. Together we can make our environment not just livable, but flourishing for all forms of life, as we strive to make the soil and water environment conducive for plant and man. Let us all remember that this is a collective responsibility. It requires the collaboration of policymakers, researchers, farmers, and communities. Together, we can promote sustainable agricultural practice that prioritize soil health and efficient water use. Together, we can develop and implement policies that support environmentally friendly land use management. Together, we can advance the research and development of innovative technologies that enhance soil fertility and soil conservation. Together, we can educate and empower communities to adopt acknowledgement. Mr. Vice Chancellor, sir, permit me to use this opportunity to appreciate all those, even though too numerous to mention, who God by divine providence have used to contribute to my success story in life. Foremost, I'm grateful to the Almighty God, the only wise God, the Alpha, the Omega, the giver of life and wisdom. I'm grateful to Jesus, who is the Word of God and the greatest teacher. I'm grateful to the Holy Spirit, the breath of God in me. Professor H.O. Fakpounda of blessed memory supervised my MSc thesis and exposed me to what is called computer and electronics in agriculture. Professor O.O. Ajibola introduced me to consultancy and made the shoulder wide enough for me to stand on in order to see far in academics. Professor M.O. Borode took special interest in mentoring me, especially when I lost my PhD supervisor at the beginning of the program. He facilitated the linkage between me and Professor P.O. Aino. Professor P.O. Aino, former Vice Chancellor of the State University and retired Professor of Soil Science, adopted me as his academic son when my PhD supervisor died. I'm grateful. Professor K.O. Adekalu, who is seated here, the leader of Soil and Water Engineering Research Group in our department. So you showed me what conducting research is early enough in my academic journey. And this can easily be seen in my earlier publications. As you see either Osunbitan and Adekalu or Adekalu and Osunbitan. Oga, as I fondly call you, sir, I'm eternally grateful. Emeritus Professor Emo Makonjuola, who, as a result of age, must be heir and Professor, and Emeritus Professor Fola Lasisi for their fatherly role in the department, Professor M.T. Ige, Professor Oe Ajayi, who supervised my undergraduate project, and not only supervising my pastor, thank you very much, sir, for all that God has used you to do in my life. And Professor Elo Adekoya,